Okay, hello friends. So hello students. So you can recall that in the last lecture I had given you a basic idea about some definitions, some fundamental behind the confounding arrangement. Now in this lecture I will try to show you that how are you going to obtain the blocks when you want to confound certain known predetermined interaction effect or main effects. As a rule, what you have to keep in mind, you have to choose the defining contrast in such a way such that the contrasts which are going to be confounded, they should not contain, say, main effect or any important effect which you want to estimate, and that might be getting confounded knowingly or unknowingly. Knowingly means you know that what are your defining contrasts, and unknowingly means those are your generalized interaction. So now let us try to have a look through these slides that how we are going to obtain different types of block, or say different blocks for a given or predetermined set of interaction effect. So now, as a rule, you have to remember that we will try to confound as far as possible higher order interaction only because they are difficult to interpret. There is no other reason. And we have to choose the independent contrast very carefully, and because it is possible that when you are trying to confound some higher order interaction, some main effect or the lower order interaction effects may be getting confounded automatically. So we have to be extremely careful. So now what is your objective? The objective is to divide the 2 to the power of n treatment combinations into 2 to the power of p groups of size 2 to the power of n minus p combinations each, and each group is going to give us a block, right? For example, in case if you take a 2q factorial experiment, and if you try to confound one effect, then you will get 2 blocks each of size 4 and 4. But if you want to get here a block of size 2, then you need to confound 2 effects, and then the block size will become 2. This is what you expect, but then you have to keep in mind that the third interaction, which is the generalized interaction, will also become confounded, because the block size which you want to make here of size 2 treatment combination, that will become practically 1. So you have to be careful, right? So this is what we meant by this statement. Now, when you are trying to obtain such groups or such blocks, there will always be one block which will contain 1, and this block is called as principal block or the key block. What do you mean by this principal block or the key block? This suggests that in case if you try to obtain the principal block or key block first, then all other blocks can be obtained from this block by simple calculation, right? So our first objective will be here, that how should we obtain the principal block. So there are certain rules to obtain the principal block which are very simple, and we simply have to follow them. So this principal block will always contain the treatment combinations which are orthogonal to the p independent defining contrast. And how to obtain them? The first step is we have to write the treatment combination in standard order. Then we need to check each one of them for their orthogonality. That means all the treatment combinations they have to be checked. And third rule is this: if somehow I can find 2 treatment combinations which are belonging to the principal block, the remaining or the other elements in the principal block can also be obtained by their multiplication. Right, and this is usually what we do as a trick, that first we try to obtain few combinations in the principal block, and then we try to obtain other treatment combinations in the principal block by multiplication rule. And this rule comes from the same concept that we had discussed during the orthogonality of treatment combinations and the orthogonality of treatment combinations versus main effects, and the orthogonality of treatment combination versus treatment combinations with respect to an interaction effect. So now let me try to take an example, and first we try to understand what are we going to do and how we are going to follow these rules to obtain the principal block, and after that how are we going to obtain the blocks. So I'm going to consider here a factorial experiment with 5 factors, that is 2 to the power of here 5 factorial experiments. So n is here 5, and I want to obtain here 8 groups, that is 2 to the power of 3 groups. So here p is equal to here 3. So I have here in this 2 to the power of 5 factorial experiment, I have here 5 say main effect A, B, C, D, E, and we want to confound, suppose 3 effects A, D, B, E and A, B, C. Well, you can choose any other effect also. My objective here is simply to take these 3 effects so that I can show you that how are you going to move further in obtaining the principal block and other blocks. So obviously once you try to choose A, D, B, E and A, B, C, there will always be generalized interaction that will be getting confounded automatically. So what are those generalized interaction? They can be obtained by multiplying 2 effects at a time and then all the effects together. So the first effect which is getting here confounded through the generalized interaction is AD into BE, which is ADBE. The second will be AD into ABC, which is here A square BCD, which becomes here BCD. And the third one is AD into ABC. AD into ABC will become here the same thing. Okay, that we already have done. Okay, BE into ABC. So BE into ABC is A B square CE. So B square becomes here 1 and we get here ACE. And then all the 3 together, AD into BE into ABC, which is here CDE. So these are 1, 2, 3, 4, 5, 6, 7. So these are your here 4 generalized interaction which are getting confounded automatically. So now I have to write all the treatment combinations in the standard order. What do you really mean by standard order? You can recall that this is here a 2 to the power of here 5 factorial experiment. So there are going to be say 2 into 2 into 2 into 2 into 2. That is 32 treatment combinations, and they have to be written in a particular order. So how are we going to do it? I can show you on this sheet and then I will continue. So you can see here that first I have to write here 1 and here A, and this has to be multiplied by here B. So this becomes here 1 into B and A into B. This is AB, and then I have to multiply it here by C. So just multiply these all the treatment combination by C, and I try to write down here C into 1 is C, A into C is AC, B into C is BC, and ABC is ABC. And then now I have to multiply this entire thing by D. So this becomes here D, 1 into D, A into D, AD, B into D, BD, AB into D, ABD, C into D, this is CD, AC into D, ACD, BC into D, BCD, ABC into D, this is ABCD. And then now this entire block will be multiplied by here E. So this will become here E into AE into BE and so on. So this is exactly what I already have written on my sheet. Here you can see, right, 1 A B A B C A C B C A B C. Now what we have to do here is the following, that our objective is to confound AD, BE and ABC. Right? Now I have to check the orthogonality of AD, BE, ABC with respect to each of this treatment combination in this 2 raised to the power of 5 factorial experiment. So now what does this actually here mean? What does this here actually here mean? That I have to check that a treatment combination has to be orthogonal to each of this effect. So let me try to take it here AD, and yeah, means whatever are the treatment combination, they will be orthogonal to all the treatment effects. They will be inside the principal block. So now I will say here, place the treatment combination in the principal block if it has even number of letters in common with the confounded effect, that is ADBE and ABC. Now how to obtain it here? Now let us try to take here AD. Now I am going to check AD for the orthogonality with each of the element over here. And how? Let us try to see. So you can see here, try to multiply AD with each and every element here. AD into 1 is 1, but anyway 1 will always be there in the principal block, so there is no issue. Now try to multiply AD with A, so that will become here A square D, that is here D, right? So then AD into B, this is ADB, right? It does not have even number of letters common, right? So essentially what I am trying to look here is the following, that the number of letters common between the small letter and capital letter, are they even order or not? So you can see here between capital AD and small a, there is only one letter which is common, that is A. Between AD and B, there is 0 letter common. So this is orthogonal. But now I also have to check whether BE and ABC, they should also have even number of letters common with respect to B. So in the first step, AD and B, they have 0 number of letters common, so that is taken as even. Now between BE and D, there is 1 letter common, that is odd. So that means this B cannot be in the principal block. So now I come forward and I try to compare with AD with AB. AD and AB, 1 letter is common A, so that is odd. So this cannot be in the principal block. Similarly, AD and C, 0 letters are common, so this can possibly be in the principal block. So I try to test for other combinations. So BE and C, yes, they have got 0 number of letters common. Now I come to ABC. Now if you try to compare here ABC and C, then there is 1 letter which is common, that is C. So this cannot be in the principal block. Similarly, I try to continue with here AD with AC, BC, ABC, and so on. I try to continue here, and finally you will see here that when I come to ACD, then what is happening? The number of letters which are common between AD and ACD, they are even. What are those letters? A and D. Similarly, between BE and ACD, there are zero number of alphabets common. So this is taken as even number. Now I try to come between ABC and ACD. Between ABC and ACD there are two letters A and C which are common. So now this ACD treatment combination is the one which has got even number of alphabets or even number of letters common with AD, BE and ABC. So this ACD will enter into my principal block. And so similarly, if I go with BCD, you can see here this condition is not going to be fulfilled. And similarly, I try to continue up to here. A, B, C, D, E, A, E, B, E, A, B, E, C, A, C, E. This condition will not get fulfilled. So, but in case if you come to BCE, then now you can see here what is happening with this here BCE, AD and BCE. They have zero letters of common, so yes, so they are orthogonal. BE and BCE, they have two letters common, B and E. So this is also, these two are orthogonal. ABC and BCE, so there are two letters common with which are B and C. Right. So once again they have even number of letters common. So this treatment combination here BCE has got even number of common letters with respect to AD, BE and ABC. So this will also enter into the principal block. And similarly, if you go with others, you will find one more. But still, now I would not like to go further, because we have understood that once I have obtained say a couple of treatment combinations which are going to belong to the principal block, then the remaining treatment combinations can be obtained by their multiplication. So now what I try to do here, that I try to put this 1 ACD and BCE in the principal block, and then I try to multiply ACD and BCE. Well, 1 into ACD, 1 into BCE, they are already here. So now the remaining is ACD into BCE. So ACD into BCE will become here A, B, C square DE. So this will become here ABDE. So now my principal block is 1 ACD, BCE and ABDE. 4 elements, and we had 2 to the power of 5 factorial experiment, and we wanted to confound P equal to 3fx. This is AD, BE and ABC. So now we have obtained the block size of 2 to the power of 5 minus 3, which is 4. Right, so 1, 2, 3, 4. These are the 4 treatment combination now which are going to be in my principal block, and you can finally check that whether that this AD, BE and ABC all they have got even number of alphabets common with respect to 1 ACD, BEC and ABD. Now similarly I will try to give you as an exercise also that instead of choosing AD, BE and ABC, in case if I try to choose ACD, ABCD and ABCDE, then you will obtain a different principal block, and that principal block will contain 1 AC, AD and CD. So I'm just giving you this as an exercise. You please try to obtain the principal block using these 3 effects and try to verify it. Now once we have obtained the principal block, then the remaining blocks can be obtained by multiplying the combination of the principal block by a combination which is not occurring in it, or simply I can say that simply try to choose the treatment combination which are not occurring in the principal block and multiply with them in the principal block, and then try to choose the distinct block. What do you mean by distinct block? You will see that when you are trying to multiply them, some other elements will come which have already been assigned to a particular block, so they have to be ignored. So let me try to show you what I'm trying to do here. Now this is my here principal block 1 ACD BCE and EBDE. Now I try to multiply the elements in the principal block by other different treatment combination. So let me try to choose my standard order, and we try to do it. So I have taken the standard order at A, B, AC, B, C, AC, BC, ABC, and so on. So now I try to choose here this here A. This A is going to be multiplied with here all the elements in the principal block. So 1 into A is A. A into ACD. Now this ACD and this here A, that is A into ACD is A square CD, which is here CD. Then again A into BCE. A into BCE here is, if we try to multiply these two things, this will become here ABCE. And similarly, if you try to multiply here A and ABDE, then this will become A square BDE. So this will become here, A square will become here 1, and this will become here BDE. So now this is my another block, A, CD, ABCE and BDE. And now similarly you can multiply here B with the principal block and you will obtain this block number 3. Similarly you can obtain here AC with the principal block, you will obtain here the block number 4. Then you multiply here by C. C into 1 is C, C into ACD is AD, C into BC is BE, C into ABD is ABCDE. So you obtain here block number 5. And similarly, if you try to multiply the block with AC, you get here block number 6. If you try to multiply it by BC, then you get here block number 7. And if you try to multiply it by ABC, you get here block number 8. So you wanted to obtain 8 blocks, each of containing 4 treatment combination. So now this is how you have assigned the 32 treatment combinations into 8 blocks, and each block is containing here 4 treatment combinations. Now the next question comes, in case if you try to choose any other treatment combination, then what will happen? Right, for example, let me try to choose here AE. So if you try to multiply here this principal block by here AE, then 1 into AE is AE. Now let us try to see here, does this AE is occurring somewhere? Not here, not here, not here, not here, not here, not here, but you can see here AE is already occurring in block number 8. So this is going to be repeated and we are not going to consider it. Similarly, if you try to multiply the first principal block by ABC, so 1 into ABC is ABC. Now let us try to find out whether this ABC is occurring in any other block or not. Not here, not here, not here, not here, not here, not here, but here. You can see here in the block number 8, this ABC is already there. So in case if you try to multiply this all other treatment combination by the elements in the principal block, you will see that they are getting repeated, and so you have to choose only the required number of, say, distinct blocks. Now once you have obtained this block arrangement, so you can conduct the analysis of variance. But so instead of going into the details of the analysis of variance, I will try to be brief Why brief? Because I already have explained you the basic fundamental theory behind the factorial experiments and their analysis of variance. So now what will happen here, that when you are trying to do here the ANOVA, what you have to keep in mind, there are essentially going to be here effects, there are going to be here sum of squares, and there are going to be here degrees of freedom, and correspondingly you will try to obtain here f. Now in these effects there will be a, b, c, etc, etc, etc. So essentially I can divide them into two parts. One are your unconfounded effects, and another will be your here confounded effects. Right, and corresponding to each of the confounded and unconfounded effects, you will have here sum of squares. Right, so these are the sum of squares for the unconfounded effects, and each of the sum of squares will carry 1 degrees of freedom. And similarly the remaining effects which are confounded, they will also have their respective sum of squares, and each of the sum of squares will carry here 1 degrees of freedom. And then you will have here sum of square due to residuals, and then finally you will have here total, and then corresponding to it you will have here TSS, and corresponding to here residual you will have here SSE. Now, so this is the analysis of variance setup when you are trying to do with a complete factorial experiment. Now in this case there are certain effects which are getting confounded. So now you try to understand what we have to make a change. This SSE will also have some degrees of freedom, so DFE. Now you simply try to add all the sum of squares corresponding to the confounded effect into SSE, and all the corresponding degrees of freedom corresponding to the confounded effects, they will be merged with the degrees of freedom related to SSE. So after this you will have here a new SSE, say SSE star, and you will have here degrees of freedom, say star, corresponding to error. Right, and then you need to obtain the F statistic. So F statistics corresponding to each of the unconfounded effect, that will be computed based on sum of squares divided by SSE, HSSE, which is the star one. If these effects were not confounded, then this SSE star was essentially your SSE, and this will follow a F distribution under H naught with 1 and degrees of freedom which are equal to DFE star, which are the new revised degrees of freedom. And this total and the total sum of squares and their degrees of freedom, they will remain the same. There is no issue. So you can see here that conducting the analysis of variance when some of the effects are getting confounded is pretty simple and straightforward, provided you understand the basic theory or the basic fundamental behind this. Right, so now you can also see that the ANOVA which you have obtained using the confounded effects and the ANOVA which you had obtained earlier using the effect which using the complete factorial where no effect was confounded, the conclusion are going to be different because your f values are going to be different. Right. So this is how you are going to conduct the analysis of variance when some of the effects are getting confounded. Right. So now you can see we have completed the topic of confounding, and in this lecture I have shown you that how you are going to obtain the principal block. Once you obtain the principal block, then all the remaining blocks can be obtained very easily. And you have seen that with the help of confounding, you are able to obtain the smaller block size. So in 2 to the power of n factorial, the block size always become half. Say 1 upon 2, 1 upon 2 square, 1 upon 2 cube, and so on. Similarly, if you are going for 3 to the power of n factorial, the theory can be developed exactly on the same lines. Here in 2n factorial, there were factors and every factor was at 2 level. But in 3 factor, what will happen? The factors will be at 3 level. For example, low, medium, high. Or say smaller, average, and then longer. So there will be 3 categories in which the observations will be classified. So understanding the 3n factorial yourself will not be difficult for you. And in that case also, in case if you have understood the 2n factorial from the basic fundamental, that how you have constructed the linear contrast to estimate different types of effects and interaction effect, the theory of 3n factorial is also developed exactly on the same lines. The next question is this. One of the basic objective of using the confounding is to reduce the block size. Now the block size can be reduced using the incomplete block design like as BIBD or say partial BIBD also. Then what is the difference between the two? Well, here in this video lecture, it was not really possible for me to cover all the things, but these things I have given you in the notes because that requires a connection from the BIBD, which I had discussed in the class. So, but in general, if you ask me, my personal opinion is that yes, the incomplete block design and factorial experiment both are helping us in making the block size smaller. But these are two different concepts. These are two different approaches to reduce the block size. And now you have understood what are the basic concepts when you are trying to reduce the block size under incomplete block design and under confounding. So the need, requirement, experimental condition, and other factors which are controlling the experiment will help you in taking a call whether you want to reduce the block size using the incomplete block design or you want to do it with the confounding. But there is also a possibility that you can use the confounding inside the incomplete block design also. So then you will have the advantages of both. The advantages of incomplete block design as well as the advantages of confounding. So this can also be done on the topic of confounding in incomplete block design or confounding in BIBD. Right, but surely these things are not really possible for me to teach you at this moment under the given conditions. So, but I am confident that if you have understood BIBD, if you have understood this confounding, it will not be difficult for you to study them yourself and use them whenever you need them. Right. So now I will request you try to take some examples from the book, try to obtain the principal block, try to obtain the other blocks, and try to do some practice of obtaining the generalized interaction, independent interactions, and this block arrangement, confounding arrangement, etc. yourself. This will give you more confidence. The last point which I would like to emphasize, that in order to obtain this confounded effects block arrangement, there is not one approach, there are several approaches. But for me, it is not really possible to take all the approaches. Some of you might have studied these topics in your undergraduate using some other approach. So one of the popular and frequent question which I get from the student is that, sir, what happens if I try to use another approach? My answer is very simple. As long as you are using the approach correctly, you are following the steps correctly, you are getting the answers correctly, I have no problem. But the only thing is this, they have to be correct. And yes, those approaches are also based on the same approach what I have discussed you. For example, if you want to confound anything, or you want to estimate the main effect or the interaction effect, I have shown you that how you can convert them into the form of a linear contrast and get it done. So similar concepts have been used over there also. So there is no issue that those approaches are wrong. You can use anyone, but that depends on you. But for me, I have a limitation of time. So that is why I have taken here only one approach. So you practice this topic, and I will see you soon. Till then, goodbye.